Welcome. This study is about human autonomy teaming in the context of search and rescue. Autonomous technology has become increasingly important in search and rescue missions. Autonomous systems can aid in locating missing people or objects, providing situational awareness, and executing critical tasks in dangerous environments. Some examples of autonomous technology used in SAR missions include unmanned aerial vehicles, autonomous underwater vehicles, and ground-based robots. These systems can operate in areas where it may be difficult or dangerous for humans to reach, such as in rough areas, dense forests, or areas with hazardous chemicals. UAVs, commonly known as drones, can be equipped with cameras to locate missing individuals or provide a bird's-eye view of the search area. They can provide situational awareness to SAR professionals to make more informed decisions. For example, UAVs can capture real-time footage of the search area, providing SAR teams with a better understanding of the terrain, weather conditions, and potential hazards. The objective of this study is to redefine the SAR process in wilderness by incorporating a collaborative effort between human and UAVs. The human search team is responsible for gathering initial information, which is then analyzed by the planning officer to devise search strategies for both the human and UAV teams, taking into account factors such as terrain, search area, and lost person behavior. Throughout the search, ongoing feedback is transmitted back to the planning officer, who can make any necessary adjustments to the plan and mission. The user interface you will perform today is a simulation platform revised based on regular SAR missions in which the area needs to be divided into smaller segments to ensure a thorough and systematic search of the area and effective resource allocation of human search teams. When utilizing UAVs to search an area, they have the ability to cover a larger expanse of land in a shorter amount of time. Thus, the area designated for UAV search is often a composition of multiple segments from a conventional search. You will act as a planning officer to decide the path of an UAV, specifically the height of the UAV for searching. The path is calculated based on lost person behavior, terrain, and offset baseline height. The influence of each parameter on the path will be visualized. During the study, you will work with 3 visualizations in 4 search missions. High level of detail presents the path of UAV. Medium level of detail presents the influence of lost person model aggregated in segmented areas. Low level of detail presents the influence of lost person model in heat map. In the adaptive mode, the visualization will change automatically based on your performance. The user interface includes 3-part. The left upper panel is a 2D map for lost person model, terrain features, and area segmentation. The lower panel has image feedback and results. You will need to select your judgment of the search result and provide a self-reported trust. The right side is a 3D visualization of the path planning. The path is pre-calculated. You can control the search, UAV, send human, or set search height. This is a demo for the operating. The briefing information will be provided. After reading this, you can start the mission. The area segments and path will be generated. Then click the search button to let UAV work. While waiting for UAV to search along the path, you can observe the 3D view by holding the right button on your mouse and dragging. After an object is identified, the image and results will show on the left. You can raise, lower the UAV to get better images, or send human team. The object detection result from the UAV has 85% accurate, and the human team has 100% sure answer. Then you can make your decision on the object and report your current trust on the whole system. After clicking the confirm, you can change the height of the next search, or you can start another search. One mission include approximately 7 searches. The whole study include 4 missions. All your decisions and operations will influence the score. The score comes from the judgment of the object, the cost comes from the time of search operations and wrong judgment. The base score is 500. Score 1 is height of the UAV in searching. If it flies high, the path is shorter, so the cost of time is shorter, and vice versa. Score 2 is the operation of the UAV or human team. Different choices have different cost of time and reflected in the score. Score 3 is the accurate of the judge of the search result. And the last score is the cost of sending the rescue team where you think the target is found. There is a training session after the introduction. After the training, there are 4 missions. After each mission, there is a questionnaire about your feelings. After all missions, there is short interview. Thank you. This is the end of the introduction.